Hey everyone, the time's come in our discussion about RIP version 2 to begin taking a look at this idea of prefix manipulation. And the question is what do I mean by prefix manipulation? Well, I mean being able to manipulate the decisions that our routers are going to make based on a case-by-case basis. Now, what this translates to is this. We are going to, first of all, look at summarization as a tool to reduce the amount of information that's going to be stored in our routing table. And then we're going to look at summarization as a tool that we can use for the purposes of traffic engineering as well as filtering information that's going to be exchanged between our devices. In order to be able to walk through this, what we're going to do is I'm going to go to R1 and I'm going to create a series of loopback interfaces. So on R1, I'm going to create a series of loopback interfaces from 100 all the way to 103. So LO 100 to 103. They will have an IP address range of 11.11.0.0/24 all the way to 11.11.3.0/24. Now, what we're going to do is we're going to advertise those on R1, and then we're going to take a look at exactly what we would expect to happen in our environment. And we're going to do that on the basis of being able to track these particular prefixes. Then what we're going to do is we're going to use manual summarization to manipulate it. Now wait a minute, Terry, I thought you said summarization was a bad thing. Well, auto summarization is a bad thing because I as an administrator have no control over it, nor do you. Now what we want to do is we want to use manual summarization on a case-by-case basis, normally on a link-by-link basis, in order to be able to manipulate what's actually happening in our environment. And what I want to do is I want to take this opportunity to be able to demonstrate and walk through that process. So first let's create those loopback interfaces. So what we'll do is we'll go to R1, and actually I've already created them. So we have 11.11.0.11 all the way down to 11.11.3.11. These are /24 prefixes. And what I want to do is I want to advertise them now. So I'm going to say config T, router RIP, network 11.0.0.0. Now that's going to automatically advertise those prefixes. Now if we look at how this is connected and how it's operating, let's see here, there's my yellow marker. We originate these on R1. They should get advertised to Cat2 and Cat1. Cat2 and Cat1 is obviously going to advertise them out their interfaces because they're all participating in RIP. Now what's going to end up happening now is that we're going to advertise this information from R3 and R2 down to R22. And what we should find in the confines of our routing table is that the DC router, the data center router that we have that we're using for testing, R22, should have two paths that we can use for the purposes of load sharing to get information to these particular prefixes. Let's look at that right now at the command line. So all I do is I'll go over to R22, and from R22 I'm going to type show IP route, and let's pick one of those prefixes. Let's pick that first one, 11.11.0.0, and hit enter. Now what we're going to see here is that I'm going to use R3 and R2 to reach this particular prefix. Now I can test this. Let's do a trace route to 11.11.0.11. And what we're going to see here is the system is telling me that I'm going to load share between R2 and R3. Exactly what we would have expected to happen based on our observations. Now what I want to entertain here is the ability to be able to change this process. Now, let's think about our conversations about IPv4 and IPv6 routing theory. I told you that the very first element, the trump of all things, when it comes to picking a prefix to include in our routing information base or our routing table, is going to be the idea of longest match. Now, the reason on R1 that we have these two entries, and I'll go ahead and take myself out here, the reason that we have these two entries on R1, not on R1, on R22, is because they have equal metrics. Metric 3, metric 3. So a hop count of 3 away from the originating source. Since our mask is the same, /24, for both of these prefixes, what I'm going to do is I'm going to resort to my testing with regard to deciding what prefix I'm going to put in my routing table. First thing I'll look at is my administrative distance. My administrative distance is the same, 120. We can see that, I'm blind here, 120. My administrative distance is 120. the metric for both of these prefixes is 3. So by virtue of the fact that I see that I have the same administrative distance, now I know I'm dealing with the same routing protocol. So that means I need to look at the metric next to determine which prefix I'm going to add. Well, we saw that we have equal cost multipathing up to 4 links. So what ends up happening is since the metrics are the same, the prefixes are the same, the administrative distances are the same, we're going to install both of these prefixes in our routing table. Now what I want to do is I want to be able to manipulate that process. And what we need to understand is that I have the capability of manipulating that process in a number of locations. So let's create a scenario right now. What I want to do is I want to use, let me go ahead and drag, I'm going to grab a dashed pin here. I want to make certain that all my traffic going to those particular prefixes goes out interface S20. Now, the reason I want to be able to do that is to make certain, let's just pretend that this link was better, it was faster. So I don't want hop count to be the determining factor. So what I'm going to do is I'm going to administratively come in and I'm going to manipulate this process. Now, the reason that we're going to look at this is, again, because we need to entertain the fact that we can do manipulation in a number of locations. Now, the point here being that I want to add a caveat to this scenario. Should we lose serial 2/0 on either R2 or on R22, I want to make certain that traffic is still going to be able to be delivered to R1's loopback interfaces, which means I need to rely on 2/1, serial 2/1, as an alternate data path. Now the way that I'm going to do this is I'm going to use summarization to accomplish this task. Now what I'm going to do is I can pick anywhere in my infrastructure where I may want to do summarization. I could do it here, I could do it here, I could do it here, here, or I could do it on these serial links. I also have the capability of being able to do this from, like I said, on a device-by-device basis. So if I want 2.0 to be used over 2.1, what I'm going to do is I'm going to go in and I'm going to make certain that I learn less specific prefixes from R3. So if I'm learning less specific prefixes from R3, I'm going to use the more specific prefixes to reach the destination, which means I'm going to travel through R2. Now, where do I want to be able to implement this scenario? Well, what I'll do is I'm going to do it on R3. So let's go into R3. And what I'm going to do is I'm going to go under my interface, interface serial 2/1. And what I'm going to do is I'm going to say IP summary address RIP. I'm going to specify the prefix that I wish to summarize. So right now what I'm going to do is I'm looking at 11.11.0.0. That's where I want to start. And what I'm going to do is I'm going to say I want the first octet to match exactly. Now the second octet, I want it to match exactly. Now on this third octet, I want it to have a range. Now what I have here is I have 4 loopback interfaces. Let's look at that. I have LO 100, 101, 102, and 103. Now the easiest way to be able to do this in this scenario, since it's constructed to be extremely simple, what I do is I have 4 networks that I want to summarize. So if I took the overall possible value here of 256 and I subtract 4 from that, that's going to give me a numeric value of 252. So all this did is give me the number that I can use here in this third octet. So let's go ahead and apply that there. So I'm going to say 252, which means I'm going to count 4 networks starting at 0. So that's going to be inclusive of 11.11.0, 11.11.1, 11.11.2, and 11.11.3. And then I don't really care what's going to be here in this particular block. And then I'm going to press enter. Now what we're going to find is that when I go back over to R22, show IP route, let's look and see what we see with regard to those 11s. All right, now here's something interesting. Because what I have now is I still have my /24s, Let's look at one specifically. Show IP route to 11.11.0.0. Well, I still have them. But here's something interesting happening. Notice my timer is now past 30 seconds. Now, we've already illustrated that if that timer exceeds 30 seconds, it's highly probable that we have a change in our infrastructure, and it's just taking RIP a long time to reconverge. Now, if it goes over the idea of 60 seconds, almost beyond a shadow of a doubt that we know we have that problem. So let's verify that one more time. Well, right now, let's see, 1 minute and 10 seconds. So we know that this is going to leave our table. Well, what I'm going to do is I'm going to accelerate this process. I'm going to say clear IP route star show IP route, and let's take a look at what we have in here for 11 now. Well, notice right now we have 11.0.0/24 right now, and I'm learning more specific prefixes from serial 2/0. Now let's take a look and see what we have here. Let's show IP route 11.11.0.0. Now notice I have just the one link. I'm not doing any load sharing, and if I verify this with a trace route to 11.11.0.11, notice I'm going through R2. I'm not transiting or load sharing across R2 and R3. Let's test this for 1.2 and .3. Well, how do I know that I'm only summarizing for those 4 particular prefixes? Let's do a test. Let's go back over to R1, and from R1, what I'm going to do is I'm going to create a new prefix. I'm going to say interface LO 104 IP address 11.11.4.11/24. Now let's see what happens over here on R22. Show IP route. Look here. As we can see, I have individual prefixes for the serial 2/0s that are only going out to serial 2/0 for the 4 summarized prefixes that we did, 0, 1, 2, 3, and 4. Now looking at this, that 4th prefix, 4, we're not summarizing it. It fell outside of the range of the summary command that we used, and what we're going to find now is that this particular value, or this prefix, is still going to be load shared. So we can see the main difference here, and I can illustrate that with a trace route to 11.11.4.11. And notice now I'm load sharing, where if I just bump it up by 1 and go to 3, what's going to end up happening is I'm actually now going to the more specific routes. Now my caveat, my stipulation was, the reason that we were doing it this way, doing traffic engineering through the concept of manual summarization, is simply because I want to make certain that I use this link while it's up. But what happens if this link goes down? Well, let's fix that. Let's go to interface serial 0 or 2/0 and shut it down. Now what that's going to do is that's going to remove all of the prefixes out of our routing table that were reachable via this idea of using serial 2/0. All right, now let's take a look and see what happens here. Do show IP route. Let's look for our 11s. Notice here they are. We have the more specific prefix, a /24 that we're learning from R1, that's being advertised by R1. We're actually learning it in this instance from R3. But notice it's still /24 and it's not a summary. But now that all of those more specific prefixes have disappeared from our routing table, what I want you to see here is I want you to observe the fact that we have the summary prefix. That 255.255.252 is actually a /22, and we can see that that's now in our routing table. Now, the moment one of the more specific prefixes appears in our routing table, this is going to disappear. So let's take a look at that. So what I'll do is I'll just shut that interface and bring it back up. Do show or do debug IP routing. And let's see what happens. I'll go ahead and erase some of this scroll here while we're waiting on that to come up. Okay, notice here, routing RIP update for 11.11.0.0/22 was learned from R3. Updated RIP for our loopbacks. Where is our 11s? So we added a prefix. Show IP route 11.11.0.0. Oh, here we go. We're still learning the 22. Updating our routing table. Let me go ahead and UL this so we're not fighting with it. Show IP route RIP, and let's see what we get. So there's my 10s. There's my 11. Notice I have my 11.0.0.0/24, and I have my 4 more specific prefixes now, .0 through .3, and I have the load sharing taking place on my 4th configuration. Now, what happens if I wanted to be able to summarize this particular, all of these? I wanted all of them to be summarized. Well, what I would end up doing is I could go back over to R3, and from R3 I would simply change my summarization. Now, we wanted to be able to advertise 4 prefixes. Now we have 5, and I want to have a summarization that's going to incorporate all 5 of them. The problem is that when we do this, we have to do this in the normal units that we're working with. What do I mean by that? Well, let me take myself out of the equation and I'll write this out. When I take a CCIE exam, or when I take any Cisco exam, I write my number line out. I go 128, 64, 32, 16, 8, 4, 2, and 1. So it's 1, 2, 3, 4, 5, 6, 7, 8. Then what I do is I do my corresponding value of 128, 192, 224, 240, 248, 252, 254, and 255. And all that is just adding these ranges. So when I take 128 and add 64 to it, it gives me 129. Now when we did our math on this, what I ended up doing was I ended up using a 252. Well, that let me advertise 4 prefixes. Well, now the only other number that I can use is 8. That's the next highest. So if I want to use an 8, I'm going to end up changing this number from 252 to 248. So let's go ahead and accomplish that right now. So what I'll do is I'll just up arrow here and I'll say no. And what I'll do is I'll change my 252 to 248. Now what's going to end up happening is the math is going to be performed, and I should start seeing summarizations being advertised for LO100 all the way to LO104 now. So let's go back up to R22 and see what we have in our routing table now. Show IP route. All right, looking at this, we see RIP has got above a 40 here. So let's repeat this command. See if it goes above 60. 54. So it's a pretty solid bet that we are no longer receiving this prefix as an update. So it's 1 minute and 2 seconds. So here, let me expedite this, and I'll say clear IP route star. Show IP route now. See if we're learning anything from that 11 prefix. Notice right here we have a 21 prefix that we're learning from 2/1. So what we did is, remember, this one right here was a 22. So it's a /22. This one is one down this direction, therefore it's going to be a /21. So now what we have on our in our table is that we should have the prefixes, excuse me, show IP route tab, just enter down till we reach 11. And what we see right now is we have all 4 of the prefixes that we are going to use now to reach. We're now using 20 like we would expect. So again, if I now trace route to 11.11.4.11, I will be just going through R2 and no longer load sharing. However, config T, interface interface serial 20, if I shut that down, now what we'll end up doing is we'll end up going through show IP route R3, using the summary. The summary was placed in our routing table. So keeping in mind we can do this on a link by link basis with regard to how we're going to be doing our advertising, and we can then get the ability to be able to use longest match to control which path our data is going to go through our infrastructure. But secondarily to that, we're going to maintain the equivalent of like a floating route that's not going to appear in our routing table in RIP until such time that we need that particular prefix. So since we're learning a 21 now versus 5/24s, we're going to pick the longer match, the /24s, over the 22. But should we lose the /24s, we're going to be able to rely on the /21 in order to be able to get information out of our infrastructure. Now, the thing that we also want to realize here is the fact that this is going to encompass additional interfaces. So I said 8 interfaces. So let me grab my eraser and point out another thing. Because what I did is on R1, I created loopback 104, 105, 106, and 107 have not been created. But by virtue of the fact that my summary address, if I follow the same sequence where I've got 411, 511, 611, 711, what we have to understand here is that the moment my summary was entered using that 248, which means I'm going to take the first 8 networks. How do I know that? 256 minus 248, 416, gives me 8 prefixes. So I'm going to take the first 8. So what I'm trying to make clear here is that any prefix that has these addresses will automatically be part of my summary. So be very mindful of how you do this. If they say, do a summarization, if you're asked in the exam to do a summarization whereby you're summarizing these interfaces, and in the future X number of interfaces would be added, make certain that your summary is going to embrace those. Now, we've looked at the idea of using summarization for the purposes of doing traffic engineering. The last element that I want to look at here is going to be for the purposes of reducing the amount of information that's in my routing tables on my devices. So what we're going to do now is we're going to go to R3 and I'm going to remove my config. Actually, let me erase this right here first. Go to R3 and I'm going to remove my summarization configuration. So I'm going to take this off. No IP summary address RIP. Now on R22, I'm going to go ahead and clear IP route star. Show IP route 11.11.0.0. We're still having it in the table, so let's just give it time to refresh. 7 seconds. We should start learning about the prefixes from both links soon. Show IP route. Did I leave the interface off? Show IP interface brief. E assigned. Yes, I did. Config T interface serial 20 no shut. Now let me make a point here. I don't edit these things out because during troubleshooting, when you're doing a configuration and it's not working the way you want it to, you will find yourself in a situation in the actual lab going in and doing troubleshooting. Maybe not necessarily in RIP, but definitely in a protocol like OSPF, EIGRP, or BGP. During your processes of troubleshooting, you're going to find yourself in a situation where you need to make a decision. Do I shut an interface down? Do I do testing? Do I run diagnostics? Do I run a debug? Do I just rely on show commands? My point is that if you bring an interface down for the purposes of doing troubleshooting, make a note to yourself in your tracking log to let you know that you did that. Because what you're going to want to do is you're going to want to make certain you bring that interface up, because that interface being shut down could cost you an entire section, if not the entire lab. So we have to be mindful of what we do, and I have a tendency to forget these things, and I don't edit these out because, again, I want you guys to understand how important it is. So show IP route. I should now have reachability through both R1 and R2 and R3 for each of these interfaces, which I do. So these are the interfaces that we created to include 11.11.0.0. So now what I want to do is I'm going to go to R1, and I'm going to go to the individual interfaces on R1, show CDP neighbors. So I am connected to Cat1 and Cat2 on interface 00 and 01. So what I'm going to do is I'm going to do my summarization there. I'm going to say I interface E00 IP summary address RIP for 11.11.0.0. And what I'm going to do is this time I'm going to do 255, 255, 252 again, because I want to advertise the summarization for the first four and the more specific /24 for the last interface. Interface E01, repeat the command here. Do show run interface E00 and 01. So now we see that I have the summary on this interface and I have the summary on this interface. Now what does that mean? That means that I'm sending the summaries out to both of these individual devices. Cat1 and Cat2. Now that's a summary for the first four and the more specific for the fifth prefix, or the fifth loopback. So let's go over to R2 and see what we have now. Show IP route. Now we've still got some residual config here. Notice I see my /22. And now I see the more specifics for 0 through 3. But let's take a look at my timers here and see what's going on. Let's see if these timers actually go above 30 seconds. So far they haven't. Let's single out one of these prefixes, 0000. Well, according to this, we're still load sharing, but our timers are at 25 and 27. Let's see what happens, if anything. Well, they're resetting. So we are sending updates. Let's take a look at what we did over here. We have IP summary address RIP 11.11.0.0 255.255.252.0 on both of those interfaces. Let's do something. Let's clear our process here. Show IP, clear IP route star. See what's going on R2 while we're doing this. Notice it's still load sharing. 27, 28, 29. We're learning the more specific prefixes. So the question becomes, what's going on here? Well, let's take a look at this and see what we've got going on. On R1, show IP route. See, let's look at connected first. So notice I have these connected interfaces, the ones that we've been talking about, all the way through 11.11.4. Show IP route. Okay, now here's something. Notice that we have 11.11.0.0/22 now, and we're load sharing, and we also have the more specific prefix of 11.11.4, and that exists because on this prefix, remember we used 252, and counting from 11.11.0.0 4 times is going to give us the capability of saying 0, 1, 2, and 3, which means 4 was not covered by this summarization. So let's verify our connectivity here and make sure that everything's good to go. Show, see, let's do a trace route to 11.11.0.11. Notice it's working, and we are load sharing. Let's try 4. And we're load sharing. Show IP route. Now the question was, notice here I have 11.11.0.0/22. I'm learning it from R3 and R2, so I'm going to load share. But 11.11.4.0/24 is still in my routing table, and I'm still load sharing. And that could be or should be expected, because all that's happened here is that we're still receiving the /24 prefix from both R2 and R3. Therefore, we're going to load share since the metrics are the same. So the idea here is the summarization only got rid of 4 of our entries out of our routing table. So let's go over to R1 and make the one last adjustment here, and then what we'll do is we'll wrap up this part of our presentation. Interface E00. Going to up arrow till I get to the summary. Let's change this to 248. 252. Let's go ahead and know it out first. We'll go 248. E01, 248, do clear IP route star. Cut over to 22, show IP route. Now notice we have a /21, and we still have this /24 in our routing table, but the 22 is now gone. And what we're going to see here is this should ultimately age out. So let's see what happens. Show IP route. $18 seconds. Let's look at it specifically. Show IP route 11.11.4.0. See, it's still telling me it's load sharing. And notice that my timers seem to be refreshing. So let's see if it goes past 30. 19, 22, 25. Notice it reset. Does that mean that my topology is broken? No, it means that RIP is exceedingly slow. Bear in mind, from R1, there are 2 devices between R1 and R22. And keep in mind, each of these entries are going to be advertised until such time that the RIP process pulls those prefixes out of its routing table, or at the very least suspects that they're down. So you may be waiting more than just the 30 seconds or the 60 seconds in order for these prefixes to stop being advertised, because they actually have to be expired from the routing table, and that's going to be one of the fundamental rules of a routing protocol that is going to use distance vector, because the distance vector routing protocol, well really any routing protocol, cannot advertise a prefix to its neighbors if that prefix does not exist in its routing table. But as long as it's in the routing table and it doesn't suspect that the link is down, that prefix will continue to be advertised. So what you're going to find is you're going to have a cascading situation when you use RIP in your lab, where you're going to have to be patient and have the comfort factor and the knowledge that you did your configurations properly, and ultimately you're going to have to wait to see the net results. Let's take myself out here, and what I'm going to do now is I'm going to see if this is still in my routing table, which it is. So it seems to be resetting for this particular prefix. So now I have to ask myself, did I do this properly? So let's go over to R1 and take a look. Do show run interface E00. Well, there it is, /28, or /248, I'm sorry, .248, which is a /21. Let's take a look at 1. I got the right configuration here. So at some point, we need to see these prefixes leave our routing table. Let's take a look at R3 and see what R3 says. Show IP route. Scroll down till we get to 11. Now notice 11 is in as a /21. Let's go to R2. R2 learning it as a /21. Show IP route. Scroll up, take a look until we see 11. Well, now we're learning it as a /21. So now let's take a look at 22. So we're still load sharing, but notice here, it's easy to get confused. We're load sharing because of the simple fact that we're still learning the /21 from two different sources. So never lose sight of that fact. And everything you need is in this command. Tell me it's load sharing, but if I scroll up and I look at all of these different show commands that we did, all the ones where I was trying to see if the timer was going to expire, notice it tells me here the entry was for a /24. Scroll down. /24. /24. /24, ultimately /21. So it does take time for it to cook out of the process with regard to being expired out of our routing table. But again, the show command gives us everything that we need to see. We still should load share because R2 and R3 is still advertising /21s, therefore the AD matches, so we know we're using the same routing protocol. The metric matches, therefore we know we're good to go there. And since the metric matches, the administrative distance matches, we know it's the same routing protocol, they have the same metrics, therefore we're going to do load sharing across those links. So with that being said, we've beaten enough of the idea of manual summarization into submission. Let's move on and look at some of our other filtering options. I'll see you guys in the next video.